We're going to do a few examples about partial fraction decomposition. To start us off, the directions say, tell whether the given rational expression is proper or improper. Well, you got to know the difference between proper and improper. A proper rational expression has the degree of the numerator being less than the degree of the denominator, not less than or equal to. And improper is when the degree of your numerator is greater than or equal to the degree of the denominator. If improper, we write as a sum of a polynomial and a proper rational expression. Well, this basically would take a division problem, similar to something, say, like 13 over 4, right? If you had 13 over 4, that would be an improper fraction. When you want to rewrite it as the sum of an integer or a whole number and a proper fraction, you would divide 4 into 13, and you would say 4 goes into 13 3 times, and you're left with a remainder of 1 out of 4, 3 and 1/4. Unfortunately for us, when you were younger, your teachers had you write them like this, major pet peeve, and then to get it to go back, they told you to multiply this by that and add that. 3 times 4 is 12, and plus 1 is 13 over 4, and we're back at an improper. Why does that work? Well, this right here is essentially our mixed number. If you were to add these now, you would use common denominator. So you have that 3, which is really 3 over 1, plus 1 over 4. You need a common denominator. The least common denominator is 4. So you multiply this on top and bottom by 4, essentially multiplying by 1. That gives you 12 over 4 plus 1 over 4, which equals 13 over 4. Now think about what you just did. You ended up multiplying this whole number, which is always over 1, on top and bottom by that. So 3 times 4. You get that answer, that product, and you add 1, because really mixed number is addition. So that's why that shortcut always worked. All right? So we're going to do that with expressions like this. Decompose the proper rational expression if possible. Okay, so looking at this, it should be pretty obvious that this example is going to be an improper fraction. Of course, you'll be expected to decide if it's proper or improper on something where the degree is equal, because that really distinguishes who knows the difference between each description, right? This over here, you can divide, even though it does seem a little strange. A lot of people are going to divide this backwards. They're going to put the wrong thing inside as the dividend and the wrong thing outside as the divisor. The divisor, which is what goes outside of your division symbol, the divisor is your denominator, and your numerator is your dividend. Your numerator goes inside. So the x goes inside, but I'm going to write it as x plus 0. And we're going to divide that by negative x plus 2. You divide the first term by the first term. So what is x divided by negative x? That's going to equal negative 1. Multiply this by this, and we write it under here. So we'll get x minus 2, parentheses minus sign, underline, cancel. 0 minus negative 2 is 2. We're done. If you line everything up correctly, you're at the end of the line. This is going to be your remainder. So 1 plus 2 over your original denominator, or the thing you're dividing by. Maybe you write 2 minus x. Maybe you want to make that x minus 2. That looks a little normal to you. Maybe it's multiple choice and you have to find that right answer. Well, if you wanted to rewrite that, a couple options. You could do 1 minus, or negative 1, sorry, negative 1 minus. If I factor the negative out of this expression right here, it'll become negative. Now the x is positive and the 2 is negative, and I could take that negative and put it right over here. So minus 2 over x minus 2. You could look at it that way. If you are going to graph this rational expression using the parent function 1 over x, and you wanted to notice the vertical stretch of 2, the vertical reflection, you wanted to see it shifted to the right 2 units, shifted down 1 unit, that's good too. Sometimes they write it with the vertical shift to the right. So another way you could look at this is negative 2 over x minus 2 minus 1. So really all of these expressions that we're seeing right now over here, 1 and 2, and last over here, number 3. Ooh, I guess I don't really need that. There we go. Well, don't mind that arrow. Okay, so these are all correct answers. Now, if improper, we write it as the sum of a polynomial and proper rational expression. Done. Check. Here, decompose the proper rational expression if possible. Well, it's not possible because my denominator is already prime. So there's nothing I can do any further to decompose this. So I've completed that part of the example. All right. So in the cloud, we'll have it rewritten as a sum of a proper rational expression and its quotient. Okay, we have one more example. The next example, same directions, okay? The next example is 2x minus 5 in the numerator and x squared minus 5x minus 6 in the denominator. So is this proper or is this improper? And I guess I didn't identify up here, so let's go over there. Oh, improper. We should acknowledge the answer to every question. This one over here is going to be proper. The degree of the numerator is 1 and the degree of my denominator is 2. So this second example is proper. So there's no division to be done here, but I can actually decompose this example. So if I wanted to use decomposition over here, switching up color a little bit, not that it's that different, I'm going to decompose the proper rational expression if possible. First thing you need to do is factor your denominator. So 2x minus 5. And you always want to be careful with these examples where the middle coefficient is one number away from your ending constant over here, because a lot of people will mix up and think multiply to 5 and add to 6. This also is a really silly example because a lot of times people get confused between using 2 and 3 or 6 and 1, or even worse 5 and 1, but that wouldn't make sense. So in this case, this minus sign tells me that both signs, my factors, are going to be opposite. One will be plus, one will be minus. This needs a negative 5 in the middle, so that means I'm going to have a negative 6 and a positive 1, okay? X and x is x squared. Take your time, use grouping, use whatever methods you need, just get the right answer. If it's multiple choice, use the choices to help you out. Okay, now from here, I'm just going to kind of draw arrows. From here is where I'm going to set up my decomposition. These are linear prime factors. They're unique. I don't repeat any factors. So the way I set these up is I'm going to put x minus 6 in one denominator. I'm going to have x plus 1 in the other denominator. I list them each as separate denominators, each unique factor. Since the denominator is linear, you'll need 1 degree less above it to be proper. So the numerators are going to be constant. So I'm going to call this one A, and I'm going to call this one B. Now I know later on down the line, people end up learning shortcuts for this. I'm not going to show the shortcut right away. I think it's important that people practice learning a system of equations approach to this first. So I'm going to leave this be, and we're going to go about it this way. So the next step, once you have this all set up, is you really want to be able to compare all of the numerators. We want to figure out A and B, so we want to compare all the numerators. If you want to compare all the numerators, that essentially means that everything either has to have a common denominator or you have to get rid of all the denominators. I'm going to get rid of them, which is essentially going to work exactly the same as if we had a common denominator. The way you do that is you multiply the entire equation over here, this entire balanced equation, by the least common denominator. If your least common denominator is not, from this side, equivalent to this denominator, you didn't set it up correctly. So you always need to evaluate that. So my least common denominator is x minus 6, x plus 1. That is what I'm going to multiply through by. Okay? Now, take your time if you get confused, but what happens here is when you multiply through by this, the entire denominator, x minus 6, x plus 1, is going to reduce down. So you're only going to be left with 2x minus 5. Here I'll have a times the x minus 6 reduces with the other x minus 6, and I'm just left with a times x plus 1. I'm not going to show as many steps in the next example. And then here b, again, it's even though reduced here, it doesn't mean you don't have it here to redistribute. Okay, you have the x plus 1 reducing, but you don't have the x minus 6 reducing this time, so it's b times x minus 6. So this is our first step in real right direction right here. So I have 2x minus 5 equals, if I distribute the a and the b, I get ax plus a plus bx minus 6b. Okay, we're doing great. Now a couple other things. The degree of your denominator is always going to tell you how many equations you'll have in your system of equations. It'll also be telling you how many different constants you'll be solving for. Okay, it's not how many fractions, but it's how many constants. So the 2 tells me that right there. Now, what happens next? What we're going to see is we're going to have to set up an equation for my linear expressions and another one for my constants. If my denominator were to the third power, I'd have 3, so I'd have a, b, and c somehow involved. I'd have a linear set, I'd have a constant set, yeah, but I'll also have a quadratic. So you kind of count up from the constant and work your way up, 1, 2, 3, so constants, linears, quadratics. If it goes up to cubics, if I end up with things all the way to the third power, that would mean this was to the fourth power down here. Okay, so these expressions over here are always going to have this number of equations, and it's always going to be, the equation will be 1 degree less, so x squared minus 1 is x to the first, so the biggest one will be x to the first. So little things to pay attention to make sure you're doing things correctly. Now, setting up my equations, so pushing all that out of the way. My linear equations, I'm just going to switch colors so we could see a little bit better. 2x has to be equal to ax plus bx. I already see that they all have an x, so I'm going to drop that right away. So 2 is equal to a plus b. And then, additionally, my constants. Negative 5 has to be equal to the a minus 6b. Negative 5 has to be equal to a plus, minus 6b. Alright, so those are my two equations. Alright, time out. Have to get my dog. Alright, so now I essentially have my system of equations right over here. I'm always going to try to solve by elimination. I just think it's way more practical. So I'm going to leave this one the way it is. I have a plus b is equal to 2. I just sort of turned around. I'm going to multiply this through by a negative, or maybe you just leave it the way it is. You leave it as 1, a minus 6b is equal to negative 5. And instead of adding them, you just subtract those equations from each other. A minus a, we eliminate. Minus negative, that becomes plus. B plus 6b is 7b. And 2 minus negative 5 is 2 plus 5 is 7. So b is equal to 1. And if b is equal to 1, well, a is also equal to 1. We'll get that from this equation when you substitute in. So I didn't show that, so I apologize, but hopefully you got that. Now over here, to write your final answer, you want to write the decomposition. So your answer for your decomposition is a, which was 1 over x minus 6, plus b, which is 1 over x plus 1. Sorry. So the final answer to this is 1 over x minus 6 plus 1 over x plus 1. Obviously, addition is commutative, so we can rewrite this the other order. Always be careful when you're comparing with your friends or comparing with somebody. If you had set yours up differently, obviously your a would be my b and my b would be your a. In this case, it doesn't really make a difference because they're both equal to 1. So again, your first step is going to be to set up the denominator in factored form. This is quadratic style quartic, so that just means this degree is going to be double that degree. You could have even a 6 and a 3. You could have an 8 and a 4. This works for any even exponent here and then the half exponent right there. We just factor it that exact same way. So that means it'll start off maybe as x squared minus 9 I'm seeing, and x squared plus 8 on bottom, but that could even go a little bit further. While this, you can't factor any further using real numbers. You can use imaginary numbers, but we don't want to do that. This is the difference of two squares, so I can change that into an x plus 3 and an x minus 3. So use my conjugates, get that factored. So I might not need this one so much, but these three, we're in good shape now. You don't factor your numerator. I'm just leaving it x squared minus 111. And now I'm going to set up my decomposition. What other things do I know? I know that this is fourth degree. That means I'm going to have A, B, C, and D in my setup. All right. That also means you're going to end up with 4 equations. So when all is said and done, I should have constants in my setup. I should have linear. I should have quadratic and cubic. Okay. Then you know you're doing it correctly. So when I got to set this up, I do have some linear factors, unique linear factors. So started off the same way. A over x plus 3 plus b over x minus 3 plus, alright, if you just put c over x squared plus 8, that's where you're messing up. We need a fourth constant. The other rule is, here I have a quadratic prime factor. Maybe they call it a non-reducible factor. I sometimes like to call it prime because you can't factor it any further. Whatever the degree of your denominator is, your numerator will be proper in a partial fraction decomposition. In order for this to be proper, this numerator could be as large as a linear. So I'm going to write cx plus d, kind of like mx plus b. Now I have 4 constants to solve for, and when all is said and done, I'm going to have 4 equations. So next step, after you set up your decomposition, you have to multiply through by the least common denominator. And who's the least common denominator? This whole thing right here is your least common denominator, okay? If we multiply through by that, what do we get? Here, you get x squared minus 111 equals timeout. Alright, sorry, back. So this whole entire denominator ends up reducing down because I multiplied through by this, which is really over 1. Everything crosses out. A, the x plus 3 crosses out, but that leaves A with an x minus 3, and it leaves A with an x squared plus 8 plus B. Same idea, the x minus 3's are gone. So I'm left with an x plus 3 and x squared plus 8. And last, we have the cx plus d, and that is going to be with x squared minus 9. I kind of multiplied those together already, the x plus 3 and the x minus 3, just to save a little bit of writing. Okay, Next step, I hate when I waste all this space over here, so I'm just going to start over here a little bit more, okay? So I just told you guys as well that this is going to go up to the third power when all is worked out. It's always going to be 1 degree less than this, but I will have that degree number of variables or constants that we're solving for. I guess they're sort of acting temporarily as our variables, but they are constants that we're solving for. Maybe it should always be just called constants because we're going to figure out their set values. They cannot change. If they were allowed to change, they'd be a variable. So like x is a variable. So I will have third degree terms. So I'm just going to start off with sort of like placeholders. So I'll start with 0x to the third plus, not necessary, but I'm going to write 1x squared plus 0x minus 111 equals. Now here I'm going to start expanding. This gives me ax cubed. Then I'm going to get minus 3ax squared. I'm going to do the inner terms right now. Minus 3ax squared. Outer I have plus 8ax. And last I have minus 24a. Okay, I counted for every single power here. So what I'm going to do as I continue is I'm going to stack vertically, so I'm adding them up. If I expand this, I'm going to get very similar terms, but I have a plus 3 instead of a minus 3, so a little bit's going to change. So I'm going to get bx to the third plus bx to the third. Inner plus 3bx squared plus 3bx squared. Then my outer is plus 8bx plus 24b. Next, cx to the third plus dx squared. We want to put that 1. I guess we could put the 1. Minus 9cx minus 9d. All right. 1, 2, 3, and 4. Those are essentially my 4 equations right there, set and ready to go. What do they have to be equal to? They got to be equal to this right over here. So if I set them all up, I'm going to do my cubic terms first, okay? My cubic expressions. That gives me a plus b plus c equals 0. These 3 equal to that. Next, negative 3a plus 3b plus d. I don't know why I put the 1 this time. And that has to equal 1. Those are my quadratics, okay? So second degree, third degree. Here, my linear. 8a plus 8b minus 9c equals 0. That equals that. And over here, negative 24a plus 24b minus 9d has to be equal to negative 111. Okay? So my system of four equations are here. What can we do to solve this? We have a couple options here. If I multiply this by 8, I can end up eliminating both A and B and solving for C. Once I have C, keep that on the side, we'll get to that later, then I can use these two equations and potentially eliminate A and B by multiplying this by 8 and then solving for D. And once you plug in D and C into either of these equations, we will have a system with just A's and B's. I can solve for A and B from there. Alright, always have a plan with these. I feel like the people who get lost are the ones who kind of just dive right in and don't have a plan. So you definitely want to have a good plan. So that means I was starting with, let's write this down a little bit. I'm going to do, I can't remember which one I said I was going to do first. So I think it was this one and this one. Okay, I'll multiply this by 8 and take it from there. So that'll give me 8A plus 8B plus 8C is still 0 because 0 times 8 is still 0. And down here, 8A plus 8B minus 9C equals 0 as well. Parentheses, minus sign, underline. Cancel, cancel. Negative 8 plus 9 is 17. C equals 0. That means C is equal to 0. So done. It is possible to get 0. Now, that definitely tells me that D is not 0. I have to have something above it. I can't not have this expression, because if I don't have this whole entire expression, this denominator won't be a part of my least common denominator. So far, so good. Next, similar idea, but this time I'm going to focus on the two equations that have D. So this one I'll multiply through by negative 8. That's going to give us, or 8, either way. I guess negative 8 this time. So 24A plus, well, I guess minus 24B plus, again, minus sorry, D. Oh, forget it. I'm just going to do this. Plus, plus and minus. So I'm just multiplying through by 8 right now because for some reason my pen and I were not in agreement. And this one I'm going to leave. So it's again negative 24a plus 24b minus 9d equals negative 11 parentheses minus sign underline. These are gone. Okay, totally going to eliminate, I promise. Minus negative is plus, so that is 10d equals, that is 8 minus negative 111. 8 minus negative 111 is going to be 119. Oh, I see my mistake. I knew it worked out better than this. That should be an 8d because I multiplied everything here by 8. Also, I guess I kind of wasn't thinking. We definitely could have divided each of these by 8, I believe, but, or no, maybe not 8, 3 at least. Definitely by 3, and made things a little bit smaller, but whatever. Okay, so if that's 8, that becomes plus, and then that's 17, 8 and 9, 17. And from there, 17 times 7, yes, so then d equals 7. So I have the d value and I have the c value. If we just fill those in over here, we can use, say, this equation. C is 0. That tells me, I'm going to go back, sort of back to basics. A plus b is also equal to 0. And if I use this one, d is 7. I'm going to do a little subbing into my head. If that's 7, I subtract it over, I get a negative 6. And then I could divide everything by 3. So if I have a negative 6, again, that's 7, subtracted over, 1 minus 7, negative 6, divided by 3. That gives me negative a plus b equals, that was negative 6 divided by 3 is negative 2. Add them together, the a's eliminate. 2b is negative 2, so b equals negative 1. b equals negative 1, that means, right from there, a equals negative 1. Obviously, the way you set up your problem in the beginning is going to affect your answer to questions like this. So my final answer that I will be getting is a negative 1 over my x plus 3. So I'm going to write my answer in the same color I started in. So let's squash it a little bit over here. So, oh, no, I didn't mean negative 1, did I? That was negative 1, so a is positive 1. My bad. So final answer again. 1 over x plus 3 minus 1 over x minus 3. My c is 0, so it's 0x plus d. So really I'm just left with a 7 on top. And I still have the x squared plus 8 on bottom. So this right here is the partial fraction decomposition of the original problem. This example over here has the difference of 2 cubes in its denominator. So before we start, we're definitely going to factor the difference of 2 cubes. The way I factor the difference of 2 cubes, I'm just going to do that on the side over here. You want to look at it with your cubing glasses or cube root glasses. What's being cubed to make x cubed? X is being cubed to make 1. 1. If that were an 8, you put a 2. If that were a 27x cubed, you put 3x. Okay? Then you'll have a linear factor and a quadratic factor. Your linear factor does not have those 3's. You take those 3's, you put them in your pocket. You save them for later, and you're left with an x minus 1 only. Now the 3's are going to come back into play when you start this little tapping. What's x times x? X squared. What's x times 1? Just x. And what is 1 times 1? 1. So what does that tell me? These are my terms, and then I use the mnemonic device SOAP. S-O-A-P. That is the same sign as the expression we started with. Same sign. This is always the opposite sign. So S-O, and then this one is always plus. No matter what, it's always a plus sign. So S-O-A-P. This is prime, I promise. You cannot factor this any further. It is always a prime or an irreducible quadratic factor. Okay? This is linear, quadratic. This is going to have a constant above it. This could have at most a linear expression above it. So factored x minus 1 and x squared plus x plus 1, and the setup for the decomposition will be an a over x minus 1 plus, let's squash this a little bit, linear again, so bx plus c over x squared plus x plus 1. As per usual, we're going to multiply through by my least common denominator. Different teachers may show you different ways. Again, I'm doing it this way on purpose because I want you to practice systems of equations and get really good at those. So that means my least common denominator will be the denominator of the original problem. You like to think of it as being in factored form. Sometimes it does come in handy, expanded, but right now we're good. Multiply that through, that gives me 14x plus 1. Now I have ABC. That means I'm going to have constant terms, linear terms, and quadratic terms. So maybe it's not a bad idea to write 0x squared out front, because I will potentially have x squared terms over here. Equals a times the x plus 1 crosses out. That leaves me with x squared plus x plus 1. Plus, I have my bx plus c over here. The quadratic expression crosses out, and I'm just left with x minus 1. Next step, I'm just going to open it up a little bit. 14x plus 1, ax to the second plus ax plus a equals bx, nope, don't listen to me, equals plus bx squared minus bx plus cx and minus c. If you really had to break it all out, you could say, oh, my constants go here, my linears go here, my quadratics go here. That would be cubics, which is also starting with the c, so we'll do the best we can. All right, what do we got? My constants. I don't know why I started with constants this time. I have 1 is equal to a minus c. Looks like that's it. 1 equals a minus c. Next, what do we got? Linear. So I have 14x, ax, negative bx, and plus cx. So 14 equals a minus b plus c. And then I have my quadratic. 0 is equal to a plus b. 0 is equal to a plus b. Now, I've gone over strategies for things like this in the past when you're solving a system of 3 variables, okay? And you have a setup like this, where maybe one equation has everything, this one has just a and c, and this one just has a and b. It's very likely that people go around and around in circles and find themselves feeling a little bit stuck and not making any progress. So you want to have a plan. What I'm going to do is and you have more than one way to do this, so I'm going to use these two, and I'm going to eliminate b. I'm going to make it so that my new equation has the same variables that this one has, or in this case, constants. So I'm going to get rid of b, so I only have a and c. If I write it underneath, I have 0 equals a plus b. b is set up already to eliminate. If I add these together, I have 14 equals 2a, that's gone, plus c. Now, you have this right here, we can use with this right here, and c will eliminate. 14 equals 2a plus c. Again, I'm going to add those together now. That's gone. 15 equals 3a. So a is equal to 5. As soon as we got one, everything, oops, sorry. As soon as we got one value, everything's a lot easier from there. If a is equal to 5, well, if we fill that in there, 2 times 5 is 10. That means c will equal 4. And again, if a equals 5, that means then that b is equal to negative 5. So I have my A, I have my B, and I have my C. Final answer, referencing this up here, we will have 5 over x minus 1 plus. Next, okay, a couple ways we could write this, but we could write negative 5x plus 4 over x squared plus x plus 1. Totally acceptable, totally fine, a little weird, but not technically wrong. What I would rather do is factor the negative out of this whole entire numerator and change this plus sign to a minus. So if you factor the negative out, again, we'll have the 5 over x minus 1, that part's fine, minus 5x minus 4, okay, negative came out, and change that also, because that came out as well, x squared plus x plus 1, and we're done. If this is open-ended, obviously it's a little bit more work. However, whenever you have multiple choice questions for partial fraction decomposition, please, by all means, use the choices to narrow down as you go. Don't work like a horse all the way through. Here's the next example, hopefully a little quicker than the last one. This is already set up and factored. So this one has repeated linear factors. You have to remember that x is really x plus 0. You treat it as a linear factor, but this is a repeated linear factor. So you list it up until it hits the degree that it is, accumulating the degrees by 1 each time. So this is just an x, and the next one will be an x squared. From here, that's done. We're going to do the same with the x plus 1. So we'll have an x plus 1 to the first power. Then we're going to have an x plus 1 to the second power. And last, you're going to have an x plus 1 to the third power. The degree of the denominator, if all is expanded, is going to be 5. That means you're going to have 5 constants to solve for, a, b, c, d, and d, which makes it pretty easy because you only have 5 places to put them. So nothing, no funny business, no linear on top, everything's linear on sides with just constant above it. We're going to multiply through by the least common denominator, which again is the denominator of the first term, 0x to the 4 plus 0x to the 2 plus 0x minus 2 equals, I'm going to go vertical. for this example again. A will be left with just an x and an x plus 1 to the third. You should be able to expand x plus 1 to the third using Pascal's triangle very quickly at this point. If not, you're going to have to go and practice that at another time. So I'm going to expand this and distribute the other leftover x with the a all at once. That will give me an a x to the fourth power plus 3a x to the third plus 3a x to the second plus 1a x. So that right there is done. Now I'm on to this one. This one, the x squared completely reduces, and I'm only left with this. So again, I'm going to expand this using Pascal's immediately and distribute the b. That's going to give me plus b x to the third plus 3b x to the second plus 3bx plus b. C will get an x squared to distribute in there. We'll lose an x plus 1, and it'll get an x plus 1 squared. It needs 3 altogether. One of them crosses out, so I will get squared, which is 1, 2, 1, if you wanted to think of it as Pascal's again, but whatever. Whatever way you like to do it. So next I will get, so that is going to be dx to the fourth plus 2dx to the third plus dx squared. There's the 1, 2, 1. It was x squared, x, and no x, and then I've distributed an x squared, so I kind of did it all in one shot. Now, oh, why did I write D? Silly me. That should have been a C, right? I don't know what I was pointing. I was pointing at the squared on the bottom, so forgive me. So I'll change those to C's in a second. After that, I'm going to do this one now. This one's a little easier because it's an x squared and an x plus 1 going in there, so give that a second to dry. So this will just have an x plus 1 and an x squared because an x plus 1 squared reduces, so that is dx cubed plus dx cubed plus dx squared. And that'll just be an ex to the second power, so plus ex to the second power. So this way, when I do this vertically, I don't recommend, if you don't think you could keep track of everything. I mean, I even messed up doing things in your head, but if you can and you want to practice it, then homework is definitely the right time to practice it. Probably not on your tests or quizzes. Save those for things that you've definitely mastered. So x to the fourth, what do we got? So I have 0 has to equal a plus c. 0 has to equal a plus c. Next. Ooh, over here, this one's kind of nice. I should just jump to that one. I guess I'll write them all out, though. 3a plus b plus 2c. 3a, 7 equals, sorry. 3a plus b plus 2c plus d. Next, my quadratic. So 0 equals 3a plus 3b plus c. 3a plus 3b plus c plus d plus e. Okay, these are my linear right there. A plus 3b is 0. So 0 equals a plus 3b. And here, b is equal to negative 2. So negative 2 is equal to b. Alright, that means I already know the value of b. b is negative 2. That also means if b is negative 2, then that's negative 6. Bring it over. A is equal to 6. I got that from that right there. If a equals negative 6, well, from here, that means that c is equal to negative 6. I have a, I have b, I have c, which means I can fill them in here and get d, and once I have all 4, I can get e. So 7 equals, let's do a little bit writing out right now, 3 times a, so 18, plus b, so minus 2, plus 2c, so minus 12, plus d. Okay, 18 minus 2 is 16, 16 minus 12, we get 4, subtract 4 over 3 is equal to d. And now for the e, I'm going to use this over here, and we will get 0 equals 3a, so 18, plus 3b, so minus 6, plus c, so minus 6, plus 3, plus e. 8 minus 12 is 6, 6 plus 3 is 9, so e should equal negative 9. Okay, now from there, I'm going to set up and write out my answer. I just didn't want to take up the space into the next problem. That gives me 6 over x minus 2 over x squared minus 6 over x plus 1 plus 3 over x plus 1 squared minus 9 over x plus 1 to the third. And that is your partial fraction decomposition all done. Alright, our last example, partial fraction decomposition, we have two quadratic prime factors. It's a repeated, really, one repeated quadratic factor in the denominator. So to set this one up, I know my denominator is x to the fourth. That means I will have 4 constants. This isn't new. This should be basically known to you. I'm sure wherever you learn this, your teacher had addressed that to you, or if you've done enough practice, it's really something that you have pieced together on your own. Okay, so my 4 degree on bottom means I'm going to have a, b, c, d, and I only have 2 denominators, so it has to be ax plus b and cx plus d. So even if you forgot a little bit, that is enough to piece together how you're going to need to set this up. And it's quadratic, so above it to be proper, you need linear. Over here, the ax plus b will get 1x squared plus 4 to multiply by. Okay, so this, I'm just going to save a little space this time. It's going to get an x squared plus 4. Down in this line, I will get ax to the third. I'm going to write the bx squared next, 4ax is next, and 4b. And then here, my x squared plus 4 squared is all going to completely be removed, and I'm only left with cx plus d. So here is my cx's location, sorry, the x is a little weird, and plus d. Ready to go. So this one's pretty quick. A has to be equal to 3, done. B has to be equal to 0, done. 4a plus c. 4a plus c has to equal 16. If a is 3, that's 12, plus c is 16, which means c has to equal 4. And then 4b plus d has to equal negative 5. But since b is equal to 0, that means d equals negative 5. Final answer, what are we going to get? ax plus b, so 3x over x squared plus 4 plus cx plus d, 4x minus 5 over x squared plus 4 squared. And that right there is your partial fraction decomposition of the original given problem.